In Tums and water, we noticed that both pots had only one brown leaf.
In addition to comparing the brown leaves of each plant, we also compared the plant height. We were initially going to compare the growth rate of each plant, but as they all grew the same, we decided to compare the height of the plant, as in how tall the plant would be standing from the soil to the tip of the leaf. So as we can see, the plant with acid was the one that grew the least at 2 centimeters tall, and then the plant with Tums and acid grew at about 5 centimeters. And lastly, the plant with Tums and water both grew at about 6 centimeters tall. This is inversely proportional to the amount of brown leaves that there are in each plant, so they could both be used as a measure to see how healthy a plant is. So that the taller it is, the healthier; the least brown leaves, the healthier. So now let's delve into the practicality of our experiment outside of the classroom.
Our experiment wasn't made to be used on large-scale farm and crop plantations. We measured the average cost of Tums to fill an average U.S. farm of 444 acres to be 300 times greater than the average cost to fill a farm with limestone. To determine the cost for Tums to fill a 444-acre farm in the United States, we converted acres to inches squared, divided that by the circumference squared of the cup that we used to hold our plants, and then divided that additionally by the average cost of each Tum tablet in order to get the amount of money, which averaged out to be about $6 million to cover a 444-acre farm. In order to find the cost of the amount of limestone required to fill a 444-acre farm in the United States, we applied the same measures,
where we found that 1.2 tons of limestone is in each acre. So considering the price per ton of limestone ranges between $12 to $45 and the average being $34.5, we multiplied that by the amount of tons of limestone in each acre and the amount of total acres to get the total cost.
and found that the amount of limestone required in cost was around only $18,000, which once again, dividing and comparing the ratio between the average cost of Tums to fill a 444-acre farm in the United States versus 1.2 tons of limestone, which is required to fill a 444-acre farm, to be 300 times less than the average Tums cost.
That being said, our project was aimed for small-scale at-home gardens where they may not have a large-scale farm mitigation strategy such as limestone. So Tums would be ideal since it's accessible to anyone, being it's available at virtually any convenience store. So after doing this experiment, we have thought of some possible ways where we could change it and get a more accurate result.
One of the ways that we have decided we can improve upon this experiment in the future on a larger scale would be to increase the variability of our test pots. If we were to increase the size of this experiment to, let's say, 5 pots per subject, as in 5 water pots, 5 Tums pots, 5 acid pots, and 5 Tums and acid pots, this would give us a greater scope of subjects to track and observe throughout this experimentation process, where we can see if the levels of height, browning of leaves, etc. will change.
Controlling more variables and increasing the randomization would reduce the sample bias in our experiment. When increasing the variability, we could also try using different types of plants because they could react differently with all of our products. Thank you so much for watching. I'm just glad our project ended up all working out, and Tom's main ingredient, calcium carbonate, worked to neutralize the acid and protect the plant.